It may not have been apparent, but Lake County did all the work, as Glenn was talking about, getting the presentation together, lining up the speaker, lining up Dr. Root. And after they did all the work, we in Ohio just kind of came along and said, hey, can we piggyback on that? And thank goodness Glenn and his colleagues at Lake County said, sure. And so that's how we are doing this multi-state presentation tonight. I think it's a great idea. And so all you folks in Lake County Audubon Society, from us in Ohio, thank you. Okay, when we get to the presentation, we want to let you know that if you have questions as we go along, you can type them in the chat. Use the chat button down there, type in your questions. That'll go to us. We'll record those, but we'll save the questions until the end of the presentation, and then we'll answer as many as we can. So at this point, I'd like to introduce you to tonight's speaker, Dr. Terry L. Root. I've had the privilege of knowing Terry Root for almost 6 years now, and I know her as a dedicated and knowledgeable scientist, as a passionate advocate for bird conservation, and as a friend. I've had the pleasure of hearing Terry talk about climate change at least twice, and I can tell you, you are in for a great presentation tonight. For those of you who have not seen her detailed biography, I'm just going to give you a few things. Terry is a professor emerita at Stanford University. She was lead author of the Intergovernmental Panel, I always have to read this carefully, Intergovernmental Panel for Climate Change Third Assessment Report in 2001. And she was also lead author for one of the lead authors for the Fourth Assessment Report in 2007 that was co-awarded the Nobel Peace Prize. And she was review editor for the Fifth Assessment Report in 2014. Now, I'm not even going to try to list the awards and honors that Terry has won, but I would like to mention one thing in particular, and that is her service as a member of the board of directors of the National Audubon Society from 2010 to 2019. I know from experience that's a lot of work. Thank you, Terry. Appreciate that. Terry earned her undergraduate degree in math and statistics from the University of New Mexico, her master's in biology from the University of Colorado, and her PhD in biology from Princeton. She was professor for 14 years at what we in Ohio in Buckeye Land describe as that school up north. For those of you who aren't in on the Ohio State jokes, that is University of Michigan. And following that was professor at Stanford for 15 years. She now lives in Sarasota, Florida. We are thrilled to have a real authority on climate change tonight to inform us and to inspire us. With that, we bring you Dr. Terry Root.
Thank you, Bill. That was fabulous. Let me do my screen sharing. And it should be coming up. Is that working for people?
I don't see it yet.
It's on my screen. It should be okay.
Yeah.
You don't have it either.
I think you have to go to that Alt.
I do.
It should be fine. I've got, no, okay.
Yeah, I still don't see it.
Okay, let's try this again.
Okay.
All right.
Now.
There you
Okay, I see it.
Good,
All
got
right.
it.
Is it working now?
Yes.
Yes.
Hey.
Yes.
Okay, well, anyway, thank you all for being here tonight. This is going to be a very, very difficult talk for me to do because whenever I talk, I walk. And I'm having to sit in a chair and can't walk around. So it's going to be very, very strange. But anyway, thank you very much for inviting me. Thank you for organizing to have that was just a huge thunderclap, sorry. Having so many Audubon groups involved, I think it was a really good thing to put all that together. So what I want to do today is talk to you about our rapidly changing climate. And people were saying, what about a title? And I said, well, it's changing birds, it's changing our weather, it's changing all sorts of things. So that's where I came up with the title, Our Rapidly Changing Climate is Changing, well, everything. And I also realize that we are working right now under a pandemic, and we all are concerned about how the pandemic is working and how can we have bandwidth to be dealing with climate change. The point is we have to, because there are two challenges that are happening at the same time. What we have to do is kind of like what we used to do when we were kids at school.
Here it is,
We would
right?
finish- we would-
Hide thumbnail video. Should I do it? Yeah.
we would talk to, we would take our class in English, and then we would go to our math class, then we'd go to our social studies class. All of them were difficult, hard to work on, but we did it. What we did is exactly then what we were doing. Okay, now all right, I'm unmuted. Okay, so the point is that we do have to worry about climate change and the pandemic all at the same time. And we can do it. We just have to put our foot forward and do it. So let's start now. Okay, that didn't work. Let's start now and talk about some of the things that have been going on recently. We've been having horrible, horrible heat waves. So if you consider the fact that at 105 degrees Fahrenheit, our enzymes start to denature. Think of what it was like in Death Valley on August 16th when it was 130 degrees Fahrenheit. The other thing that is happening a lot is we're having a lot of fires. This is a fire that happened in Australia last year, and I chose this one instead of using a picture of California this year because I want you to notice, please notice the smoke on this picture. It has been drawn by an artist. The artist is Kevin Stargram, and he has drawn in the two koalas, because that reminds us that when we have fires, it's not just the plants that are dying, it's also animals, and that includes mammals, birds, amphibians, reptiles, the whole gamut, and we have to be worried about that at the same time. So now let's talk a little bit about what I'm planning on doing today. What I want to do is I'm first going to talk about climate change since the beginning, basically, of the Industrial Revolution, since 1850s. Then I'm going to switch gears and go into future climate change. I don't have a crystal ball, but we do have some guesses of what might be coming, and I want to talk about those because we've got to be ready for them. Then this is Audubon, and this is near and dear to my heart, is we are going to be talking about what about our birds, because climate change is affecting birds and we've got to do something about that. And then I will finish it all up by talking about what we all can and must do, because as Bill said, the birds are going to be affected by climate change, but they can't do anything about it. The only people who can do something about it are people, and we've got to do something about it, and we can. There's a lot to do. Now, let me warn you, the first, second, and third parts of this talk can be very depressing. Now, don't get too concerned, because I promise, the fourth part will bring you up, and it will make you feel like there is hope, because if there wasn't hope, I wouldn't be bothering giving a talk. There's a lot of hope out there, and we're going to find it. Okay, on this is a slide that is showing you global temperature change, and this is actual temperature change. It's going around in circles, and it's going by years, and it's the change from an average of early in the Industrial Revolution until basically today. And you can see it keeps getting warmer and warmer and warmer. Let it go through again. But we're always looking at the change relative to what it was before the Industrial Revolution. So that's what's happening. And these are the actual data. And you can see it was cooler back in the 1920s. And now the 40s are getting warmer. The 60s are getting warmer. The 70s is when it really starts getting warm. boom, and then it's up. And I don't have any data past 2017, so I have this plot that shows you the global decades of warming, and this is again for the whole world. And so the last bar on this one right here, is the last decade, and that includes all the data up through 2019. And you can see that if you look on this, you can see that the last decade was 1.2 degrees C above natural. And natural is what I'm talking about before the Industrial Revolution. So we have warmed significantly. So that's 1.2 degrees Celsius, which is 2.2 degrees Fahrenheit above natural. We really have warmed. Now, if you look at what has gone on just in the United States, this is since 1970, when the very first Earth Day occurred, and I'm sure many of us can remember that. So from 1970 to 2019, the United States, the average in the United States has warmed by 2.4 degrees Fahrenheit. Again, that's quite a bit in that time period. Now, what's going on in different areas? Well, let's talk about Chicago. Here's Chicago. This is the average low temperature in the summer nights. And it goes from the same data points, the 1970 out to 2019. And it's only warmed by 1.1 degree Fahrenheit. And that doesn't seem like much. And the reason it isn't very much is it has to do with the lake effect. But now if you look at what's going on in Columbus, holy mackerel. Over the same time period, we're looking at the exact same thing, average low temperatures at summer nights. It has warmed by 4.5 degrees Fahrenheit. So it really has warmed a lot. So you can really see the difference. Here in Chicago is 1.1, here in Columbus is 4.5. There is a big effect of those Great Lakes. Now, as we're talking about warming, we talk about warming on land, and we kind of forget about the fact that the oceans are warming too. So let me show you what's going on in the oceans. And this is showing you the heat change, the heat content in the ocean. And what it's doing is it put a 0 for the average between 1981 to 2010. And it's just showing you how that is changing. And look at how much warmer it is here, sorry, at this end than it is down at this end. So the oceans are warming, and that's not good when we're talking about sea level rise. And sea level rise is a real issue that we have got to deal with, certainly here in Florida. And the lakes are also warming. The water in the lakes are also warming. And so their edges are going up, the coastal edges are going up too. And so we've got to worry about the seabirds that are, or the shorebirds that are along the shores. Now, why is all of this happening? This is a plot that goes on the x-axis, starts at now, which is here. And when I say now, I actually mean yesterday. The data that I got from here came from yesterday. So we start here, I've lost my pointer, there it is. We start at now, and we go all the way back to 800,000 years ago. So this is a lot of data, and we've been able to take these data from ice cores and the like. And on the y-axis is parts per million of CO2 concentration in the atmosphere. And you can see that for 800,000 years, it never got above 300 parts per million until now. And now is us. Now, I actually had to change this number. I gave this a talk with this slide in it about 2 months ago. And that number, the 411, was actually 415. And it now has dropped, and it's dropped because of the pandemic. But still, 411 is really quite high for the CO2 concentration in the atmosphere. CO2 is a greenhouse gas. It absorbs the heat, it acts as a blanket and doesn't let the energy back out into the atmosphere. So it's actually warming the planet significantly. That's why CO2 is such a concern. Okay, so now that's what has gone on in the past. Now let's talk about future climate change. How does the climate, how is it actually going to react to all of these changes that humans are doing to the climate? Well, again, we don't have a crystal ball, but what the Intergovernmental Panel for Climate Change has done, what just happened? I don't know what this yellow line is, but anyway, on the x-axis is years, and on the y-axis is parts per million of CO2 equivalent. And equivalent means that it includes CO2, carbon dioxide, but it also includes methane, it includes water vapor, it includes all sorts of gases that are seen as greenhouse gases. And what the Ipcc did, the Intergovernmental Panel for Climate Change did, they said, let's come up with different storylines. And that's what the different lines are on this plot. The black line is business as usual. We're not going to change one thing. We're just going to keep going the same way we've been going forever and ever. And if we do that, we follow along this black line. And when Obama was president, we were a little bit below it. When Trump came in, we went a little bit above it. When the pandemic hit, we now are back down below it. So the pandemic is doing good things in some ways. Okay, these other lines, the blue and the green one, what those are assuming is we have a very egalitarian society. And it depends upon how much sharing and interacting is going on as to whether we're on the blue line or the green line. But by having sharing of technology and things like that, we are able to bring the business as usual line down, and we're not going to have as much greenhouse gas going into the atmosphere as we would otherwise. Now, the other line here, this red line, is one that I have a lot of concern about. Because what this line is they said, they did this in 2016, so right around here. In 2016, God clicks her fingers and all greenhouse gas concentrations stop going up into the atmosphere. All of a sudden, as if by magic, it completely stops. If it completely stops, wouldn't you assume that that line would drop quickly? So you're going along and it's not dropping. Why is it not dropping? The reason is because CO2, which is a very strong greenhouse gas, stays up in our atmosphere for about 1,000 years. Other gases don't. The methane, which is a very strong greenhouse gas, is only up in the atmosphere about 10 years, but CO2 stays up in the atmosphere for 1,000 years. So now what that means is the CO2 that we are putting into the atmosphere right now, when we have our air conditioners on, or in Denver and Boulder where it's snowing and now they have their heaters on, that CO2 is going up in the atmosphere and is going to stay there for about 40 generations. So that's equivalent to what we are doing right now is affecting our great, 39 greats grandchildren. That's really staggering to think. What we are doing today is affecting our great 39 greats grandchildren. So that means what we are doing is very important. What we are doing today is very important, and we need to be doing something to change this course of action so that we get off of this business as usual curve, the black curve. Okay. Now, one of the ways we can do that is to stop our horrible fossil fuel addiction. And so we need to stop using our fossil fuels. Well, on this slide is showing you the areas that are open to new gas and oil leases for Bush administration, Obama, and Trump. I'll show you again. Here's Bush. Here's Obama. And here's Trump. We can't have that much oil and gas going up into the atmosphere that is going to be mined by what Trump is allowing. It's just way, way too much. It's going to put us way above that business as usual curve, and that's going to be a disaster. So we really have to stop that. We can't have that happen. Now, this is the same type of plot I showed you before. The only difference this time is that it is actually showing you estimated temperature, not actual temperature, because it's going to go up all the way to 2100. It's getting warmer and warmer and warmer and warmer. Oh my God, by 2100, if we stay on the business as usual curve, we could go out to 5 degrees Celsius above natural. We won't be able to sustain that. That's not going to be able to happen. There's a lot of things that will go on, and we can talk about that later if you want to, but we will not be able to sustain our planet if it goes up to 5 degrees C above natural. So we have to do something about that. Okay, let's talk a little bit about sea level rise. Sea level rise is a really tough thing to talk about because we don't really understand how the melting occurs. And we know that when ice gets hot, it melts, of course, but we really don't understand how the glaciers are melting and things like this. So there's a lot of slop when we're talking about sea level rise. Part of sea level rise comes from the warming of the water, which expands and pushes it up farther up. But in 2018, the sea level was 8 inches higher than it was in 1880. We know that for a fact. So now, what happens in 2050? Well, we don't know precisely. The low estimate from the Ipcc is 19 inches. So that would be 11 inches more from 2018 to 2050. That's a low estimate. The high estimate is 31 inches. And I just read a paper about 9 days ago, I guess now, saying that we are closer to the high estimate than we are going to be to the lower estimate, is what they're assuming. Now, what happens if we go to 2100? 2100, the low estimate is 6.5 feet of sea level rise. We're assuming that the person that's standing here is 6 feet. And that's the low estimate. The high estimate is 9 feet. 9 feet. Now that doesn't even take into account storm surges when we have hurricanes and things like that. The other thing that it doesn't take into account is this. This is the Greenland ice sheet, and it is melting. And it is melting very, very rapidly. And in that ice is 27 feet of sea level rise. So if you have that much water coming out, we're going to have a lot of trouble with sea level rise. And in the past 2 weeks, they have found that they think that we are past a tipping point, that we are not going to be able to stop Greenland from the Greenland ice sheet from melting, and that it is going to melt all the way. So that's 27 feet of sea level rise. And Antarctica is also going to be melting at the exact same time. And that has a lot more water in it than the Greenland ice sheet. So we really don't want to get this Earth so warm because it's going to shrink our land masses because the sea level is going to go up so high. So this is a real concern. And the scientists have just said they think that we are past that point for Greenland. We're not past that point for Antarctica, but we may be past that point for Greenland, which is a very scary thought to think. Okay, so the Ipcc scientists, they're scientists from all over the world. There's about 2,000, when I was working with it, there's about 2,000 of us around the world that were working together. And they decided in October of 2018, they came out with a study and said, we need to tell you guys that we are serious. We are very concerned about what's going on with the climate changing. And we're going to tell you what needs to happen so that it doesn't get so warm that we are really endangering our planet. And what they decided to do was say we must limit our global warming to 1.5 degrees C or 2.7 degrees F above natural or above the Industrial Revolution time. So we need to have some big changes. So in 2010, this is just showing you gigatons of CO2 put out per year. 2010, it was less than 40 gigatons. 2017, oops, we're still going the wrong direction. We're still going up. We needed to be going down, but we're not. But what the IPCC said in October of 2018 was 2030 needed to be 45% of what it was in 2010. They were actually able to come up with a number and say, this is what we have to do. And then they said by 2050, we have to be down to zero gigatons of CO2 being emitted per year. Is that possible? That's going to be very, very difficult because we are a plastic society and plastics come from fossil fuels. And so we're still going to be mining fossil fuels. We're still going to be emitting methane from those wells. So it's going to be a tough thing to do. But anyway, having it down to zero at 2050 is going to be very difficult. Having it down 45% of what it was in 2010 by 2030, that's going to be tough, folks. We have 10 years. We've got to do it. So now, what the IPCC said, the scientists said, is we're not going to stop right there and just not tell you anymore. We're going to actually tell you what has to happen. So they gave us a recipe, and it's wonderful. One of their recipes is in the transportation sector. You have to have an increase in low emission vehicles. So by 2020, we need to have this, remember this report came out in 2018. We need to have 5%, about 5% of our fleet, our transportation fleet, be in low emission vehicles. Did we make it? The US did not make it, but the world came very, very close. Then they say that what we need to do is by 2050, we have to have between 35% and 65% of our fleet be low emission vehicles. Can we do that? I actually think we can. I truly believe that we can do that. We just have to decide to do it, and we can. I truly believe that. The other thing they said was they said the electricity market has to change over and have a large percentage in non-biomass renewables. So I'm talking here about windmills, I'm talking about solar panels, I'm also talking about nuclear. I'm a person who actually demonstrated against nuclear power back in the 70s, but we can't take nuclear off the table right now. Maybe in the future, but not right now. And also in here is hydro. But by 2030, we have to have about 50 to 55 to 60% of our electricity market needs to be non-biomass renewables. And by 2050, it needs to be between 63 and 81. Now, let me tell you, I gave a talk, probably about a year ago now, to the American Wind and Wildlife Institute. And it was the audience, there was about 300, 400 people there. And the audience, half of the audience were people who worked on wind turbines. And I put this slide up and I said what I just said to you. And the whole audience erupted in laughter. You know how it feels to have people laugh at you and you're not making a joke? So it was kind of tough. And so finally, after the laughter stopped, somebody in the back said to me, yelled out above everybody saying, that is absolutely impossible in America. Okay, it may be impossible in America, but let's hope that it's not impossible in the world. And as we realize how important climate change is, America gets on the bandwagon and actually is able to help reach this goal in 2050. I think it's possible. It's going to be a hard one, but again, we can do it because we really don't have a choice. We have to do that. Now, I'm talking to Audubon people, and we all love birds. That's why we're in Audubon. Well, I was on the board of Audubon, as Bill said. I was on the board with Bill. And people are shocked when Audubon and, well, I came out and said, we have to have wind turbines. Because people say turbines kill birds. Turbines do kill birds. But when you're talking about small birds, the songbirds, the passerines, one turbine kills about 3.7 birds, small passerine birds per turbine per year. 3.7 small birds per turbine per year. Now, turbines do kill larger birds, and we're figuring out ways to stop that. And they do kill bats, and we're working on that. Those are two tough things to do, but we need to be working on them. But turbines are what we need, because we're talking, if we're not going to have turbines, then we're going to have such a hot world that we're going to have extinction of birds, and we don't want extinction of birds. So we've got to have turbines, and the National Audubon Society is very strongly in support of wind turbines, because we've learned a lot over the years on where to locate them so that we're not killing as many birds as, say, the Altamont Pass did when it first went up. Now, so what in the world is killing our birds? Cats. That's it. Look at the difference. Over here on the left-hand side, cats are killing about 2.4 billion, that's with a B, billion birds are being killed by cats per year, because we have 80 million feral cats in North America. And we have 80 million domestic cats in North America. So they are killing a lot of birds. But then if you go down here and you go towards the right, window kills are high, autos are killing some, power lines, towers, electrocution, and here are the turbines. Orders of magnitude lower. So we really do have to have the turbines in order to save our birds. That's what it's going to take. So that's the future of climate change. So now let's specifically talk about our birds and what's happening with our birds. a study came out recently that said that that since 1970, again, since Earth Day, the first Earth Day, we have lost 2.9 billion birds. That's a staggering, staggering figure. What that amounts to is 1 in 4 birds that occurred in 1970 is gone. And those of us who are as gray-haired as I am realize that, because we go out birding now and there are a lot fewer birds out there than there used to be. So this is what has happened. And now on top of this, we are going to also have what could be happening in the future with climate change. So now I want to talk to you a little bit about how birds are affected by climate change. This is a picture of a polar bear. I actually took this up when we went up to the North Pole once. And the polar bear had killed a seal. And what polar bears do is they kill the seal and they flip blood and guts, literally, all over the place. And then this little guy, see this little guy here? The ivory gull goes around and eats that blood and guts that has been spilt around by the polar bear. Well, as the climate has warmed, there's been less and less ice in the Arctic. So the polar bears are not going out on the ice floes, so they're not killing seals. That's good for the seals, but it's very bad for this ivory gull, because now the ivory gull doesn't have the blood and guts to feed on. And the ivory gull population is plummeting. And I'm 66 years old, and I would be willing to bet you $1 million that the ivory gull is extinct before I die, unless I'm hit by a semi truck or something. This little guy is in trouble. And the point is that how one species affects another species affects another species. And that's what's happening now with climate change. Now, one of the things that's happening too with climate change is things are happening earlier in the spring. So on this plot, on the x-axis is years, and on the y-axis is date index. And what they did was they put 0 at 50, I think it was 58 years. I think it's 58, it may be 59. I don't know. Yeah, I don't know, I don't remember which it is, but anyway. And what they did was they looked at when birds were arriving on migration in Asia, in North America, and in Europe. And all of them are coming earlier and earlier and earlier over the years. And so that's why this plot is showing this decline in timing. So it has changed by almost 9 days from 1959 to 2015. That's quite a shift. That's quite a shift. The other thing that our birds are doing is they're shifting their ranges. Their ranges are shifting up in elevation and toward the poles. So in the northern hemisphere, they're going up north. Now, this is a study that was done by a colleague of mine, John Terborg, in Peru. And he did it in 1985. And he looked to see along this mountain where the different birds were. Well, up to 800 meters occurred the common scaled-backed antbird, which is here. From 800 meters up to a little bit above 1,200 meters is where the versicolored barbet occurred. And then at the very top of this mountain was the variable antshrike. Now, he kept such good notes that more recently, they have done a same transect to look and see where these birds are. And this was done in 2017. And now the common scaleback antbird is shifted and is above 1,000 meters. The versicolored barbet goes all the way up to 1,400 meters. Uh-oh, the variable langstrike has popped off the top of the mountain. So right now, the species that are in the most danger are the species that are at the tops of mountains. And so the variable langstrike is one that we need to be worrying about. The other thing that we have to remember is as we have gone around and multiplied our own numbers, our population numbers, we have built huge habitats of human settlements. Now, can you imagine, think of yourself as being a butterfly and trying to fly through this and finding nectar flowers along the way. It's going to be a tough thing to do. So yes, species have moved in time and millennia, but they haven't had to deal with the scars that humans have put on the planet. So the farms, the factories, the freeways, all of those things are now in the way, and we've got to worry about that. Now, Audubon did a study, and it's called Survival by Degrees. And what they have found is 389 of our North American birds are on the brink. They are at risk of extinction. This is 2/3 of all North American species of birds. That's quite a statement. And this is what Bill was saying earlier. Birds can't fight climate change, but we can. I urge you all to go to this, to the website, audubon.org/climate/degrees, or survival by degrees. And then you can type in your state and it will tell you what birds are going to be at risk. And what Audubon did was they took data from over 140 million observations, and you can see where a lot of those are. And they looked at climate, they looked at vegetation, human land use, group-specific variables, things like water for water birds, desert for desert birds. And at the 1 kilometer squared resolution, we're able to tell us what might be going on with our birds. And this is quite a powerful study. I urge you to go and look at it. And let me just show you for one bird. This is the current summer range for the Scarlet Tanager. This is a bird that's near and dear to, I'm sure, all of your hearts. And now, if we warm, and let's hope it's a if we warm to 3 degrees Celsius above natural, this is what that range is going to look like. And what that says is 68% of the Scarlet Tanager range is going to be lost. 32% of it will be stable, and then it will move up north, assuming the habitat is available. There'll be 24% expansion of its range. But Chicago and Columbus are going to lose their Scarlet Tanagers in the summertime if we go to 3 degrees above natural. Now, what Audubon did was say, let's look at what happens if we only go 1.5 degrees above natural. And here it is. So now only 32% is lost, 68% is stable, and 18% is gained. So this is a much better scenario. This is what we need to be shooting for, and we can shoot for it, and we can do it. Now, what Audubon shows that if we go up 3 degrees, which is 5.4 degrees Fahrenheit above natural, there are 15 highly vulnerable summer species in Illinois. And those species include the eastern whippoorwill, the red-headed woodpecker, the fish crow, the wood thrush, the brown thrasher, the field sparrow, Savannah sparrow, Hinslow sparrow, eastern towhee, bobolink, worm-eating warbler, cerulean warbler, yellow-throated warbler, Canada warbler, and the Scarlet Tanager. Wow. those are a lot of pretty special birds that are going to be endangered. That's pretty sobering. So now, what if we just go up 1.5 degrees C above natural, or 2.7 degrees Fahrenheit above natural? Then we only have 5 birds, which is much better than 15. The tundra swan, the least tern, which has to do with lake levels. The fish crow, Henslow sparrow, and the yellow-throated warbler. So that's much better. So we do need to get off this business as usual, and we do need to decrease the amount of CO2 and other greenhouse gases going into the atmosphere. That brings me now to talking about extinction. This is the golden toad, the first species that was shown to go extinct by global warming. It's a toad, a very small toad in Costa Rica. And a colleague of mine monitored it, and 1 year it didn't come out, and he's been watching since, and he has concluded very nicely that this is an extinction due to climate change. But now all species go extinct, and biologists have the background extinction rate is less than 1 species in 1,000 species over 1,000 years. Now what that means is if you have a room and you put 1,000 species in it and you watch it for 1,000 years, less than 1 of those species will go extinct. Now, what's the extinction rate now? It's about 1 species in 10 species, not 1,000 species, over 100 years, not 1,000 years. So we have very, very, very much accelerated extinction rates on our planet. Now, the IPCC fourth assessment report in 2007 came out and said that when we go up 2 degrees C, which is 3.6 degrees Fahrenheit above natural, we could lose about 500,000 species due to extinction. Since we know that there are 2 million species on the planet, those are the 2 million we're thinking about. So this is 1/4 of the species could go extinct if we go up, or when we go up 2 degrees C. If we go up 4 degrees C above natural, we could lose half the species on the planet. And this I have a lot of trouble with. What is the moral right of 1 species, us, causing the extinction of half the species on the planet? The other way to think about this is I guarantee you that some of those species that we cause to go extinct, we're going to need to stay alive. So it's going to make our life very difficult to stay alive as those species go extinct. Okay, now that everybody is completely depressed, what I want to do is I want to talk to you about what we can and what we must do, because there's a lot of things that we can and must do. The first thing that we have to do is we have to have a paradigm shift. And we have had paradigm shifts in the past, a lot of them. Here's an example of one. Food will win the war. We observe meatless days, wheatless days, porkless days. This is one of the paradigm shifts that it was seen to be patriotic to have meatless days, wheatless days, porkless days. And this was in World War I when we were fighting overseas. And so we were saving the wheat and the meat for the men and our allies overseas. And it caused a paradigm shift, and it worked. We've done it for smoking, it works. We're doing it for women's lib, it works. We're now doing it for Black Lives Matter, that will work too. But we have to have a paradigm shift for climate change, and we can do that too. This to me is one of the most positive slides that I have. What it shows is tons of CO2 emissions per person in 2016. And what it is showing is this is DC, New York, California. Here's the US in the middle of the orange. Illinois on one side, Ohio's a little bit higher, but not much. And then we go to these crazy states over here, West Virginia, North Dakota, and Wyoming. What's going on in Wyoming, North Dakota, West Virginia? They're burning coal. That's what's happening. But look down here at the green ones. They know what we can do to actually pull the tons of CO2 emissions down. And when I used to live in California, I used to say, a Californian has never met a regulation that they don't love. So we know how to do this. California is showing us, New York is showing us, DC is showing us. We just have to have people like West Virginia, North Dakota, and Wyoming listening to us. So people say, well, it's horrible that humans are causing climate change. It actually isn't horrible that humans are causing climate change, because if we're causing it, we can stop it. So that's a good thing. And that's what this plot is showing us. One thing that we must do is we must be planting native plants. All of our birds need native plants. Please, 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 please don't ever plant another non-native plant in your yard. We don't need it. All of the species that are going to be trying to move around in our landscape need those native plants. How do you find out what native plants grow in your area? Go to Audubon. Audubon has this fabulous, fabulous website, audubon.org/native-plants. You type in your email address, then you type in your zip code, and up pops a whole list of all of the native plants for your area. It is fabulous. And I've taken advantage of it. And before I pulled out my whole front yard, my husband and I pulled out our whole front yard and planted native plants. Before we had 3 species of butterflies. Now we have over 12 species of butterflies. So it's really fabulous. It really works. And please don't ever plant another non-native plant. Okay, so where's the greenhouse gas sources coming from? Electricity is 28% in the US. Transportation is 29%. Agriculture is primarily from beef, but some from sheep too, is 9%. Commercial and residential is 12%, and industry is 22%. So now, what needs to be done? For electricity, we need to have renewables. For transportation, electric vehicles. Agriculture, plant-based diet. Commercial and residential, zero emission buildings. We should never build another building that is not a zero emission building, because we know how to do it. It just costs more. We just have to do it. And then we have the industry. Industry is a real tough one. And I really don't know what we can do about that, but what we need to be doing is supporting research and development. But now, what can every single one of us that is watching this talk, what every single one of us can do? What can we do? For electricity, support wind farms. I know we're Audubon, we need to be supporting wind farms. Install solar panels on your roof. That's a great place to put solar panels. Buy only Energy Star appliances. You can go to the government website for Energy Star and it'll tell you which ones are the best. And if you have any incandescent light bulbs, throw them in the landfill. And I was horrified last Christmas to realize I had incandescent light bulbs. Your Christmas tree bulbs may be incandescent. Throw them away, get LED. Okay, for transportation, the next car you buy, make sure it's a plug-in car. And I have a good friend of mine who saw this talk and has just decided to buy an electric car. Woohoo! We all can have electric cars. We can have plug-in cars. If you don't want one that's just electric, get one that has gasoline too. But it needs to be getting about 50 miles on an electric charge. The other thing we can do is we can all make fewer trips, combine our trips together, and it'll work. Okay, for agriculture, we all can do meatless Mondays, and maybe meatless Thursdays, and maybe meatless Sundays. We can do that. I have a friend who every single day, she picks one meal that is non-dairy and non-beef. That works too. Come up with a creative way to have meatless or dairyless things in your diet. You can do it and you'll feel better for it too. Commercial and residential. Everybody can get an energy audit from your electricity company. They'll do it and they'll love to do it because they'll love to tell you how to turn down the amount of electricity you're using. The other thing is turn up or turn down your thermostat appropriately and turn off and unplug items that you're not using. I have a toaster that when it's plugged in, it's telling me all the time, it's ready to toast, it's ready to toast, it's ready to toast. At 4 o'clock in the morning, it really doesn't need to tell me that. So I unplug it when I go to bed, or when I'm not using it. Then you come to industry, and industry is a really tough one. So what I say is we've got to do planting of trees. How do you get all of this CO2 out of the atmosphere that's going to be there for 1,000 years? The best way to do that is to plant trees. The best company by far, and I've done a lot of research on this, that plants the right kind of trees in the right places is a place called cooleffect.org. It is a fabulous, fabulous, fabulous website. So please go to cooleffect.org. I don't own any stock in it. I have just gone through, and there are so many people who plant trees, but they're planting non-native trees. That does no good. We've got to have, well, it does some good, but it doesn't do good for the birds. We need to be planting the right trees, and Cool Effect does that. So when you fly on if you ever fly on an airplane again, you can go to Cool Effect and say, I'm going to fly so many miles. They'll tell you how many trees they need to buy, to plant to do that, and you give them the money and they will do that. The other thing that you can do is they're great Christmas presents. You can say, well, my brother has this high of a carbon footprint and I will offset that. It's a great Christmas present and it doesn't clutter up the house. So go to cooleffect.org. The other thing, and the most important thing that we can do right now, is you've got to vote, you've got to vote, you've got to vote. Your voice really, really matters. So please, every single one of you, make the commitment to vote. We've got to vote. Now, this is a picture that people who have gray hair like I do remember when this was taken. This was on the day before Christmas, 1968, and it's called Moonrise. Look how fragile our Earth looks. It's a very, very fragile planet, and it's the only one we've got, folks. We've got to take care of it. We've got to take care of it for us, and we've got to take care of it for the other plants and animals on this planet. We can do it. There are many, many, many things we can do. I've told you many, many things that we can do. We just have to have the political will and the oomph to do it. And I hope I've given you a little bit of oomph to do it tonight. So thank you so much for listening. Here is my email address and also my phone number if you want to get in touch with me. So thank you again. I really appreciate you listening.
Thank you, Terry. The one thing we can't do is applaud, or at least you won't hear it when we applaud, but I invite everybody at home to applaud anyway. Okay, for those of you still here, and it looks like most of you are here, thank you for sticking with us, and we have time for a few questions. Terry will kind of play it by ear in terms of how many questions we can get in, but I have some that people have submitted, so let me read a few to you. First, and I'm going to go with this one first deliberately, what are the most hopeful signs of global action that you've seen?
Oh my gosh, hopeful signs. I would put that all to the young people and what they are doing. They get it. They know that this is a problem, and they know that there's solutions, and they're out working towards them, and they're going to do it. I used to teach, as you said before, I taught it at Stanford, and I had a class that I taught that was called environmental literacy. And at the end of the class, they said, we're sick and tired of hearing all the problems. Let's try to figure out what can we do for solutions. And then they asked me to teach a class on solutions. I didn't teach it. They actually did it themselves. They are the ones who are doing this. And us old farts kind of have to get out of the way and let it happen. So to me, that is my biggest hope, is how much the young generation is doing.
Great. Let me throw in a comment here. Speaking of hopeful things, a recent study, somebody pointed out that a recent study showed that painting one blade of a 3-bladed wind turbine black reduced bird mortality by up to 70%.
Yes.
The mechanism is unclear, but it's an interesting thought there.
Yes.
Okay, another question. And Terry, I'll ask this, but you may not want to say too much because this is probably another talk or two. How do we think about changing individuals or groups who are in denial or changing their mindset?
Let me show you a slide I have. It's Chasing Ice. This is a movie that was done, it's a documentary, and what it is doing is showing people ice melting. It sounds really boring, but it is just absolutely spectacular. And I happen to be in the movie as a talking head. That's not why I'm pushing it. I'm pushing it because it is so good. But being a talking head, I actually went to openings of this movie, and I would stand out in the front, and people would go in and say, oh, this is a bunch of bunk. And then they'd come back out and they'd say, oh my God, maybe it's not a bunch of bunk. So what I suggest to people is what they do is they invite their friends over that are kind of on the fence or are really not thinking that climate change is important. Have dinner and show Chasing Ice. And there's not much else you need to do because it really shows how the planet is changing because it is warming. Now, there are people that I don't care what you do, what you say, how you say it, when you say it, where you say it, that they are going to change their minds. They're not. And those people, you just have to say, we have to agree to disagree. You're wrong, I'm right. Anyway, you have to just disagree. But most of the people that I interact with are just kind of on the fence and they want to know what to do. You can stream Chasing Ice from Netflix. There's a sequel to this called Chasing Coral that is absolutely spectacular. I recommend it too. But Chasing Ice is the way that you do that.
Okay, great, thanks.
Sure.
Another question, a very specific one. Will some ocean shorelines become uninhabitable due to greater frequency or intensity of hurricanes?
Storm surge is a real issue. So what we have is sea level rise and storm surge that is occurring. And the governments are getting to the place now where they're saying we're not going to rebuild in specific areas because of the possibility of storm surge. So the answer to that is absolutely yes. We've got to just become realistic and say we cannot build in those places anymore and risk all those people.
Okay. What about, another question is, what's your opinion, or what about potential technological advances, to remove CO2 from the atmosphere? Are these things feasible?
Yes, there are a lot of different technologies that are trying to pull the CO2 out of the atmosphere. The trouble is that they're using more energy than they really should be using, and so it's causing a lot of CO2 to be produced to pull it out of the atmosphere. Now, if you capture it as it's being produced and you sequester it, that may be okay, but we're still in the area where it's still gray. and I just don't know of any technologies. A very close friend of mine is working on it. He's now at Harvard, and he thinks he has figured out how to do it. I'm skeptical. Will technologies eventually come available? Probably. But you have to remember that getting a technology up and running takes 30 years. So having the idea, they've shown this time and time again, having the idea and getting it up and running to scale takes a minimum of 30 years. We don't have 30 years to waste. We have 10. So it's not going to help us in the short run. It may help us in the long run, but not in the short run.
Okay. This is a question for you and I think for Doug or Glenn. Will this presentation be available to watch later?
As I understand it, it is being recorded. Glenn, you, Doug, what's?
Yeah. I started recording right about in the middle of Glenn's part of it. So we'll have almost all of it.
Great. Thank you. And we'll distribute that information, of course, to our participants along with some other links and so on. Next question, why is CO2 the most mentioned greenhouse gas? There are others, right?
Yes. Why is it the most mentioned? Well, it's because it stays in the atmosphere for so long. It comes from fossil fuels. It is a potent greenhouse gas. Now, methane is a much more potent greenhouse gas. It's about, well, I don't want to give figures because I don't know precisely, but there's a lot less methane than there is CO2 in the atmosphere. So that's why CO2 is the thing that is the most concerning, and it's because it's something that we generate the most of from our electricity and from driving, transportation, things like that. Yeah.
Okay. Another comment that somebody pointed out was that when we're speaking of wind power, there were several days in the recent past, and I don't have the details, when England was actually giving away electricity. In fact, they were paying people to take electricity because their amount of wind power they generated was so great. There were some very windy days, apparently, so it can be done.
It can be done, that's right.
Okay, let's see, we had a couple other questions. Bear with me.
You're doing a good job, Bill.
Thank you. What would you say are the main roadblocks to influencing the fuel industries or similar to adopt or move toward more sustainable alternatives?
Money. I think they just don't want to, they really don't want it to switch over because they're going to lose a lot of money. There's a lot of oil in the ground that they can get up, and it can get it up for relatively low amount of money and make a lot of money. But that being said, there are a lot of industries that are very, very interested in switching over. And I think that's one of the ways that we can help get out of the pandemic blues, the economic pandemic blues, is by actually helping people to switch to green power instead of renewable power, instead of fossil fuels. But the fossil fuel companies are strong. They have very strong lobbies in politics. And so it makes it very hard to change things around. And we have to have the political will to do it. And it's going to take one of these paradigm shifts. It's going to it's a patriotic thing to have solar panels on your house. That's the type of thing that's going to happen.
Okay. Doug, how are we doing on time here? Do we have time for a couple more?
Sure. Yep. No problem.
Okay. Here's one that we've heard, that some of us have heard multiple times, I'm sure, but it's a sample of a question, I suppose. But we sometimes hear about emissions from volcanoes or similar things like that. How do human CO2 emissions compare to natural sources?
Well, I think the best way to look at that was the CO2 emissions back for 100,000 years. The CO2 emissions were always below 300 parts per million. And now that humans are on the scene, it's a lot more than that. So yes, volcanoes do put out CO2, but they do not put out nearly as much as the humans do and sustain it. So that's the problem.
Okay. Another question, how does climate change, how does all this tie into habitat conservation in the neotropics? We've seen real issues down there. Do you see connections to climate change in terms of saving species?
The issue with down in the tropics is important because that's where so many species do occur, and we do need to protect them. The other thing is that as we are burning off those forests, which are not used to being burned, we're changing the weather patterns in those areas, and that is causing everything to get drier, and it's having effect all the way around the planet. So the tropics are a place where we really do need to be focusing our attentions on making sure that we are keeping species safe, and by cutting them down and putting in palm oil, for instance, palm oil plantations is really devastating, not just the species, but also the climates, the weather that is around in that area. So we somehow have to encourage South American countries to not be burning their forests. And we can do that, but we need to be helping them, not just telling them.
Okay. Another question, and this may be beyond any of our expertise here, but we'll ask it anyway. In the Chicago area, would investment in solar or wind be more prudent? Or how would one decide these sorts of things?
Oh, the Nature Conservancy just put out a map, not just, about a year ago now, put out a map showing where the best wind areas are in the US. And you can see how it goes in the Chicago area. I just don't know that off the top of my head. As far as daylight, I don't know how much daylight there is in Chicago, but there certainly is enough to support having solar on top of houses. It's a best place to put solar because it's not destroying any other habitat. The trouble around Florida, where I am right now, is that it is very, the electric companies don't want us to be putting solar on our housetops. They want us to be putting solar in these great big huge solar farms. The trouble with that is it's destroying habitat. Where in my house, I've already destroyed the habitat. All I have to do is put the solar on top of my roof, and I'm not destroying any more habitat at all. And so we're trying to change the laws here in Florida to really support rooftop solar instead of big fields of solar. And I would assume that in Chicago, it would work the same way. But in all honesty, I really don't know how much solar there is, how much sunlight there is in Chicago off the top of my head, so.
Well, I can add to that and say here in Ohio, you can successfully put solar up there on the roof, and it is very doable, and it takes a while to pay off, of course, but that time is getting shorter and shorter as the technology for solar panels improves and the cost of solar comes down pretty substantially. So we got one for Ohio. Ohio's doing something right.
The other thing that is true too is when you put solar on your house, you can plug in your electric car and you get the energy for free. So you're not having to put any money into the car to actually make it go.
There is that. Okay. There was a question about fossil fuel production. The question is, you showed fossil fuel production for the US, but what about the rest of the world or around the world? I don't.
I don't know. I'm not going to be able to answer that well. I'm sorry.
Okay. That's
Yeah.
fine.
Don't know.
And somebody remarks that they have solar panels on their roof in Chicago. The estimated payback period is only 7 years, and they are very happy with the way it's working.
Fabulous. Fabulous.
And I think that is the questions that we have. I may have missed one or two. If so, I apologize, but I think we've come to the end of the list for the moment.
Okay.
Great.
All right.
All right. Well, I wanted to thank everybody for participating and signing on. And I think everybody's learned quite a bit from this, and maybe have small discussions going real soon. I know every time you were talking, even with the questions, I was thinking of answers for some of these that are pertinent. And one of them is that solar panels are much more efficient now, and they do pick up very low light and change it to energy. So it's getting better and better. And in our neighborhood,